Let's do some guided practice. Limits at infinity. So there are going to be three scenarios, right? When the power on the top is less than the power on the bottom, when the power on the top is the same as the power on the bottom, or when the power on the top is greater than the power on the bottom. And of course, I'm talking always about leading terms. So let's take a look. Again, I always rewrite the expression. Right, because we're going to be doing something to it. Now, in this situation, we have infinity over infinity, right? We have an indeterminate form. We can't leave it like this. Even if you know the right answer, if you just wrote the correct answer, then I would not give you credit. I'd give you a progressing at best. Because you have to show why the answer is true, why you know the answer is true. So here, you can divide as you wish, but I think it's best practice to divide by the lower leading term. Lower leading term. This is going to give you limit as x approaches infinity of 2 plus 7 over x squared minus 4 over x cubed. All over it. Now the bottom, also be careful when dividing, but you get that. Again, repeated fractions, no one's favorite, but they work out pretty nicely here. Right? I'm going to plug in infinity, so to speak. I mean, not really plug in, but as x gets larger and larger, we wind up getting 2 plus 0 minus 0 divided by, well, let's see. It's kind of blowing up there a bit. Now, that's pretty crappy notation, part of my language. Pretty lousy notation to just write infinity like that. Maybe I could just write big. Right? Big. So, the top is a constant, right? 2. The bottom is blowing up. So what happens? Your answer is 0 because your fraction is getting smaller and smaller. Let's look at the next example, right? The power in the leading term equals, or sorry, the leading term, the power of the leading term in the top equals the power of the leading term in the bottom. So what we're going to have is, well, again, an indeterminate form. So again, you don't have to write parentheses infinity over infinity, although I think it's good just to verify that we need to do something here. Here, you don't need to worry about dividing by the lower leading term, right? It's the same. So we're going to get something kind of nice, right? We get 4 minus 1 over x to the 4th. Bottom is going to be 7 plus 3 over x squared plus 1 over x to the 4th. And sure enough, I'll do it over here. When we plug in big values of x, we get 4 minus 0 over 7 plus 0 plus 0 equals 4/7. Last but not least, we have the case where the power on the top leading term is bigger than the power of the bottom leading term. So if we just write this out, well, then what are we going to get? Well, we always have infinity over infinity, right? We can see that. So what do you think we're going to divide by? Well, again, it's the lower leading term. You can do the higher leading term if you want, but I think lower is just a little easier to see how things work. I would never take off credit if you divided by x to the 4th, but I think it's better to divide by x cubed in this case. Right. So what happens here? Well, when we sort of think about x getting bigger and bigger, plugging in infinity, so to speak, we get, well, big plus 0 over 3 plus 0 minus 0. So maybe you can see what's happening. That's going to give us infinity. If I could write it properly. There you go. So let's just look at a pattern here, right? When the leading term on the top has lower degree than the leading term on the bottom, we wind up getting 0. When the powers of the leading terms are the same, we wind up getting the ratio of their coefficients. And when the power on the top is bigger than the power on the bottom, we get infinity, or maybe negative infinity, depending on whether there's a negative coefficient, right? Those are the only three possibilities.